Our next topic is initial value problems. To understand what is initial value problem, let's start with a simple example. dy by dt equals y. We can solve this equation using separation of variables. dy over y equals dt. Log of y t plus c1. I'm going to suppose that y is positive, so I will not use mod values here. I've used c1 for a reason that I'm going to simplify this function and change its form. We can put both sides of the equation into e power. This is a correct step in algebra. Now on the left hand side, e and log will cancel each other and we will get a y. And on the right hand side, we would like to split this into 2 and write like this, which is again from algebra. C1 is a constant, E is a constant, universal constant. So e power C1 is also a constant. We can rename this constant as C because C1 is unknown constant. We don't know what this constant is for now. What is the value of this constant is. So we will represent this one with C. It will not change our solution. Right. So our solution becomes y equals C e raised power t. This is a very well-known function, exponential function. If we would like to make graph of this function, we can easily make graph of this function to understand it a little better. For example, here I have graph of this function. Obviously, I will have to suppose some values for C to plot the graph. If C is 1, then my curve is here, this curve. If C is 1, so I'll get this curve. Y equals e power t, C is 1. If C is 2, it crosses at 2. If C is 3, if C is 4. So all these are different curves for different values of C. Similarly, if C is negative for -1, this one for -2, and this one for -3. Now, yes, we know this function. It's an exponential function. It increases really fast. Question is, if somebody asks, or let's say if I tell you that this equation is about population of a bacteria, and I tell you that y represents number of bacteria in a culture, number of bacteria present in a culture at time t, and t is the time measured in minutes. Now someone asks me that I have solved a differential equation and I have got a function as an answer, as a solution. Can I answer this question? How many bacteria are present So if somebody asks us how many bacteria are present at t equals 10 minutes. Can we answer this question from our solution? If we put t equals 10 minutes, t equals 10, we get c e power 10. But what is c? We do not know what is c so far. How do we find c? We use initial conditions to find value of c. What are initial conditions and where do they come from? It will come from the data we observe or note at the start of the experiment. For example, let's say at the start of the experiment or observation, there were 2 bacteria present at time t0. This is what we call initial condition. Mathematically, we write it like this: y of 0 equals 2, where this is the value for t and this is the value for y. Now we use this condition in order to find c in our solution, y equals c e power t. We put 2 here, c e power 0 here, and that tells us that c equals 2 because e power 0 is 1, so c equals 2. So for this condition, this particular condition, our solution becomes y equals 2 e raised power t. Now we can answer the question which we were asked: how many bacteria are present at time t equals 10 minutes? So at t equals 10 minutes, y equals 2 e raised power 10. That's the number of bacteria present at time t equals 10 minutes. If the initial value is this, you can easily note that if we change the initial value, that will slightly change our solution because that will change our c, and that can change this number. Just to see this, before I go to another initial condition, let me show you this thing in the graph. From here, we can make infinitely many functions because c is a real number and there are infinitely many possibilities. But once we are given an initial condition, we get one of those infinitely many curves. It could have been the one from the negative side. That depends. In our example here, maybe not, but in some other example, maybe yes. So for this initial condition, which I have written here as a point, or we write it as y of 0 equals 2, this is the curve the initial condition chose for us. And we used it to answer this question. What if the initial condition was different? Let's say if initial condition was y of 0 equals 3. There were 3 bacteria present at the start. That means our solution will be c e raised power t implies 3 equals c e raised power 0, and this means c equals 3. And our solution becomes y equals 3e raised to power t. Now when we answer the same question again at time t equals 10 minutes, now the value becomes y equals 3 times e power 10. When the condition was y of 0 equals 2, the value at 10 minutes was 2 times e power 10. And when the condition is y of 0 equals 3, the start value has changed, our number has changed. A very important question here would be that will the answer, whatever we are trying to study, always change when the condition is changed? The answer to that question is no. That is also one point in studying all these physical phenomena, to see which initial condition affects the phenomena, which initial condition affects the phenomena and which does not. I'll give you a couple of examples to understand the story a little bit better. Let's see at these examples. Let me copy them into our lecture notes. Right. In the first example, we have an electric circuit and we want to study current passing through the circuit. I represents the current. And that current is studied using this differential equation, which is a first order differential equation. When we will solve this differential equation, obviously we will get a constant of integration, just like we have a constant of integration here because of the integrations here. Right. That constant of integration, we can find the value of that constant of integration using an initial condition on our current. At time 0, the current is 0. This initial condition will tell us what is the value of that constant, and then we can answer any future questions. For example, at time t equals 10, let's say the one we did in the previous question, what is the current at time t equals 10 minutes or seconds? So first we need to find the constant which we will get from the solution of differential equation. Right. In the second example, we are adding brine into a tank, and of course there is an outlet as well. Now if there is some salt already present in the tank, we can use that as an initial condition to study this whole system. So at time 0, the amount of salt A in the tank is given by 10. That will help us find the constant, the unknown constant, which will occur while solving this differential equation. For this pendulum problem, the equation is second order differential equation, d2 theta over dt square, where theta is the displacement of the pendulum from the vertical axis. Our initial conditions, we need 2 of them. For a second order equation, we need 2 conditions. I have not written the second one. For a second order equation, we need 2 conditions because there will be 2 constants, 2 unknown constants. And we use 2 conditions to find 2 constants, C1 and C2. And then in this question, in this pendulum problem, we figure out that The frequency and the period of the pendulum does not depend on this initial displacement theta. If you leave the pendulum from here or from here or from here, the period of the pendulum remains the same. So that is the kind of things we study using initial conditions and differential equations. Right. Let's do one more question on how to our question is question number 23 of the same exercise. Dy by dx equals 4 times y squared plus 1, and the initial condition is y of pi by 4. Now this value is for x and this value is for y. Right. Clearly the equation is separable. Dy over y squared plus 1 equals 4 dx, and then we integrate. Does anybody remember integral of 1 over y squared plus 1 dy? Arc tan of y 4x plus c. Note that arc tan of y is same as tan inverse of y. You might have used this notation in calculus, tan inverse of y. Arc tan is exactly the same as tan inverse. This book uses this notation, so I will use this notation. Right, now we put our initial condition, x equals pi by 4. I'll write here again. X equals pi by 4, y equals 1. Please be careful when you extract the values from the condition. Do not put y equals pi by 4 and x equals 1. That will change the solution. Arctan of 1 equals 4 times pi by 4 plus c. This implies pi by 4 plus not plus equals pi plus c, and this implies c equals minus 3 pi by 4. Pi goes to the other side and subtracts. Right, our solution becomes arc tan y equals 4x minus 3 pi by 4. Just one quick terminology I will introduce. So we saw the solution y equals c e power t. This is called one parameter family of solutions. Why is that? One parameter is very clear from this c. This c is the parameter, and family of solutions, as we have seen in the graph, that for each value of c we get a different function, a different curve. So this is a family of solutions in this one function, and that family is being decided by this parameter c, one parameter. So that's why we call it one parameter family of solutions. And after applying the particular condition, the initial condition, let's say our initial condition was y equals y of 0 equals 2, and that gives us this solution. This is called particular solution. particular solution. This solution is particular for this initial condition. If you change the initial condition, particular solution will change accordingly. Just a terminology thing. Now, I believe you can easily do following practice problems. This is the minimal list of practice problems. You must do these 3 problems at least. And for the complete list of practice problems, please see the course page. Please try to do as many problems as you can. That will help you understand the whole concept more easily.